Okay. And the second method of preparation, it is starting with the uracil. So uracil means in a 6-membered ring, if the 2 nitrogens at 1,3 position, okay, and 6-membered ring with the 2 nitrogen at 1,3 position and a carbonyl, okay, functional containing 1 is called uracil. So, but here, what is this? This is a dihalo, okay, and this carbon is called carbene, okay, dihalo-carbene uracil, disubstituted uracil. When it is treated with alcohol, alcohol may be ethanol, propanol, methanol, whatever it is. So the lone pair present on the oxygen, it can attack this carbon, cyclopropyl ring junction carbon. Then what will happen? A migration of this bond. Okay, this bond will go over here. When this bond is going over here, halide will go out. So that is how the a 7-membered ring is obtained. 7-membered ring, more particularly 1,3 diazepine is obtained. So that means 1,3 diazepine is can be obtained, can be prepared or synthesized starting from dihalocarbene uracil compound when it is treated with alcohol on heating. Okay, so this is another method. So with this, I will go to a next slide. Oh, next slide. I have to take a next slide. Okay, I will go to the next slide. Right. Okay, here it's about the chemical properties. So this is the number. Okay, don't worry about this. This is the first chemical reaction. This one will be the second chemical reaction. So 1,3. Okay, 1,3 diazepines. Okay, this is 1. This is 3. 1,3 diazepine reacts with acid. Okay, acid means H plus to give 1 amino pyrrole derivatives. Okay, so what it means, when 1,3 diazepine it's treated with acid, it will give you a pyrrole derivatives. How means, this is the mechanism part, and if we are looking into the reaction mass, reaction part, 1,3 diazepine when it is treated with acid, it will give you the pyrrole substituted product. So if you are looking into the mechanism, the lone pair present on the nitrogen or maybe a bond pair can react this proton, forming a protonated amine. Once there is a formation of protonated amine, then this bond weaks. When this bond pair is moving towards the nitrogen to convert it as a lone pair, then the lone pair present on the other nitrogen attacks this carbon, forming a new bond between the between the nitrogen and then carbon. So then what will happen? There will be a removal of methanol. How it will remove? The lone pair present on the more particularly this allylic hydrogen. So how it will go? Again, the lone pair present on the oxygen can abstract one more proton and form a oxonium ion. Once there is a formation of carbocation on this oxygen, then this bond try to move towards this. That time the bonded pair will come over here, and this is how a pyrrole substituted this product is formed when 1,3 diazepine is treated with proton may be from HCl or sulfuric acid or PTSA or any sulfonic acid or any proton source. So one more reaction, 1,3 diazepine. 1,3 diazepine when it is treated with N-phenyl selenyl phthalimide. N-phenyl selenyl phthalimide. That means N you can write adjacent to that Se. Se is called selenyl, and then CH2 and then phenyl. So on the other side there will be a phthalimide group. Okay, on the other side there will be a phthalimide group. So one side phthalimide, phthalimide means what, you know that, no? N, CO, CO and then benzene ring, that is called phthalimide. Okay, so N-phenyl selenyl phthalimide, when it is react with 1,3-diazepine, so there will be a bond formation between this carbon. Okay, that is how a SV bond formation here, and here there should be, you can also write CH2 phenyl. Of course, phenyl is there, no, phenyl, fine, phenyl only, not the benzyl. Okay, phenyl selenyl 1,3-diazepine. Then what will happen? I think you are familiar with this kind of rearrangement. When this moiety is treated with base, the base abstracts this proton adjacent to the selenyl group 1. Then this bond pair is coming over it. This will go out. So that is how a double bond is obtained adjacent to the nitrogen. This is another reaction of 1,3-diazepine. So with this, I will go to the next one. Okay, I will take it. I will go to the next slide. Next slide. Right, it's coming. Now we are discussing about 1,4-diazepine. So 1,4-diazepine means nitrogens are at the 1,4 position. So this is 1, 2, 3, 4, fourth position. So this 1,4-diazepine can be synthesized or prepared or manufactured starting from 1, 4. Okay, this is 1, 2, 3, 4. Maybe what you can say that 1,2-diamine, ethylene diamine. Okay, otherwise you can, this group is called ethylene, and these two are diamine, ethylene diamine, and then 1, 3 dicarbonyl ketone, 1, 2, 3. So 1, 3 diketones. So what it means? It means that 1, 4 diazepines are prepared starting from ethylene diamine and then 1, 3 dicarbonyl compound. What will happen here? A condensation reaction, removal of H2 and O going out as a H2O, removal of H2 and O going out as a H2O. So what will form here? So the obtained one rearranges. How it rearranges? Migration of proton from one position to third position. So that means this bond pair can come over here and this can fix up this proton. So rearranges, giving rise to product 1, 4 diazepine, more particularly 2, 3 dihydrodiazepine. Okay, so this is one method. I will go to the next slide. So next slide here I am taking, I think you know that without this double bond, this double bond means this is a of course how this particular compound is prepared. So here 1, 2, I think you know that this is the cyclopropane. So this is 1, this is 2. That means 1, 2 diaminocyclopropane. 1, 2 diaminocyclopropane, when it is treated with benzaldehyde, it gives a skip base like this. Okay, so I know you know that this on heating, what will happen? It's a cope rearrangement. I think you come across in pericyclic reaction. How it will movement? I think you know that if you want to find out whether the one is cope or oxycope or whatever it is, then you have to 1, 2, 3, and then 1, 1 dash, 2 dash, 3 dash. That means it's a 3-3 sigmatropic. In general, it's called 3-3 sigmatropic rearrangement. So what will form? Okay, this bond pair will come over here, and this bond pair form a bond with this carbon, and this bond pair going over here. It's called 3-3 sigmatropic involving. Of course, it can be called as a cope rearrangement. So what is 7-membered ring is 7-membered ring is formed. Then afterwards, hydrogen shift, 1-3 shift, more particularly 1-3 shift. This bond pair can come over here, and this bond pair picks up this proton, and the formed one is called 1, 4 diazepine. So these are the two methods of preparation of 1, 4 diazepine. One is starting with the ethylene diamine and 1,3-dicarbonyl compounds. Another is starting with the from the cope rearrangement followed by one sigmatropic hydrogen shift. So with this, I will go to the next slide. So next slide is about the chemical reactions. So here the chemical reactions means what will happen when 1,4 diazepine is treated with acid. So that means it's you know that this bond pair can come over here and this bond pair can come over here and this bond pair can picks up this proton. Okay. So what will happen? Since there is a lone pair involved in a bond formation, so this nitrogen attains a positive charge and there will be a new bond formation between the nitrogen and proton. So this is what obtained. So this formed positive charge will be stabilized by resonance. So that means this bond pair can convert as a lone pair. So then this bond pair moves over here and this bond pair can come over here. That is how the another canonical form is obtained. So if you want to write the resonance hybrid, one can write a resonance hybrid like this. So that means the positive charge is moved from this nitrogen, this carbon, this carbon, this carbon, and this carbon. So that means if you are looking into the resonance energy, if this energy is less, then this will be the stable one. So then what is the application of this? This application is there more particularly. So the application is when this moiety is treated with electrophile. Okay. So what will happen? There will be a new bond formation between this carbon and electrophile. So this carbon means what? It's a sixth position. Sixth position, there will be a electrophilic substituted product is formed. And this is about the application of 1,4 diazepine when it is treated with acid source. So this is how the product is obtained. So with this, I will go to the next one. So that is the nucleophilic substitution reaction. So nucleophilic substitution reaction also is possible at the sixth position. If there is a leaving group is present on the sixth position, nucleophile can attack here and the leaving group will go out. So that is how what is called as alkoxide. Okay, alkoxide is obtained starting with bromo. Okay, 6 bromo. 2,3 dihydro, these two 2,3 dihydro, 1,4 diazepine. So with this, I will go to the next slide. So next slide, suppose I think now we are discussing about the sulfur and nitrogen containing 7-membered ring. So sulfur and nitrogen containing 7-membered rings are called thiazepines. Thia means sulfur, aza means nitrogen, and epine means 7-membered ring. So thiazepine. So this is the one I am talking about. And how one can synthesize or prepare the thiazepines. More particularly, you know that this position, okay, is fifth position. Okay, how it is fifth position? You can say this takes the first priority one. So 1, 2, 3, 4, 5. Fifth, 5 amino. 5 amino pentene. There is a double bond is there. Pentene, sulfonyl chloride. That means here there should be E, pentene, not the pentane. So 5 amino pentene sulfonyl chloride. So 5 amino pentene sulfonyl chloride. So you know that this is a nucleophile, this is a electrophile. That means it's a intramolecular reaction. So the lone pair or the bond pair can attack here and there will be a 7-membered ring formation and the obtained one is called thiazepine. Okay, maybe now what you can say that 1, 2 thiazepine, 1,1 oxide, dioxide. So that's what you need to mention. So it is also thiazepines also is it is also possible to prepare starting with ketone. Okay. Okay. Right. Okay. So what is happening here? A amine. Okay, amine is treated with sulfur. Of course, this is a ketone. Okay, right. Overall, the following ketone reacts with the amine. So here I am taking aniline. Okay, and this is the ketone. This ketone contains, okay, two groups. One group is acetylene group. Another group is there is a double bond here. Okay, there is a double bond here, and then sulfur is there, and this is cyanide, nitrile, of course, cyanide or nitrile. So what we can say that, so you know that thiocyanate, this is called thiocyanate, and this group is called vinyl. So what we can say that acetylene, vinyl, thiocyanate, ketone. So what will happen? The nucleophile attack the sulfur and the CN will go out. What it means? It means that there is a new bond formation between the nitrogen and sulfur. Once there is a new bond formation between the nitrogen and sulfur, later lone pair or the bond pair present on the nitrogen, there will be a bond formation with this acetylene carbon. So this is how 1,2-thiazepine 5-one, a 1,2-thiazepine is obtained. This is another method of preparation of thiazepine. So with this, I will go to the next slide. So next slide is about 1,3-thiazepine. So that means here sulfur and nitrogen are at the 1,3 position. How this is obtained? Starting with a compound like this. So what is the name of this compound? This position is called bromo. 4-bromo and 4 carbon atoms, butyl. And this moiety, this functional group is called isothiocyanate. So 4-bromo butyl isothiocyanate, when it is treated with amine, so you know that the nucleophile attacks this carbon. Why it is attacked this carbon? Because this carbon is electron deficient. Why this is electron deficient? Because it is attached to a 2-electron withdrawing group, electronegative group. So when nucleophile is attacking here, this bond pair attack this carbon and this bromide will go out. That HBr is going out, and the formed product is called 1,3-thiazepine. And it is also thiazepine is a 1,3-thiazepine. It is also prepared starting with this is a vinyl group. Okay, and this is azirine group. So more particularly aziridine. Okay, so vinyl aziridine, when it is treated with phenyl, this is called phenyl, and this group is called isothiocyanate. So vinyl aziridine, when it is treated with phenyl isothiocyanate, so what will happen? There will be a 6-electron. Of course, initially there will be a bond formation between this sulfur and nitrogen. So forming thioamide. How it will form? Maybe the lone pair present on the nitrogen or bond pair can react this electron deficient carbon, forming a thioamide. So later on, you know that Cope rearrangement or 3,3 sigma-tropic rearrangement. So this is a 3,3 sigma-tropic rearrangement. So 1 dash 2 dash 3 dash 1 2 3 3 sigma-tropic. Of course, this you can call it as a yes, maybe in general you can call it as a 3,3 sigma-tropic rearrangement. What will happen? This bond pair is coming over here, and this bond pair, there will be a new bond formation with this carbon, and this bond pair is coming over. That is how 1,3-thiazepine is obtained. So with this, I will go to the next slide. So next slide is about the 1,4-thiazepines. So 1,4-thiazepines, how 1,4-thiazepines means, you can observe that sulfur and nitrogen are at the 1,4 position. So 1 2 3. So 1, 2, 3, 4, fourth position. So how the 1,4 thiazepines are obtained? So you know that this is the bromo, okay, and this is amino group. 1, 2, 3, 3 bromo propyl amine, 3 bromopropyl amine when it is treated with thioglycolic acid. Okay, this is called thioglycolic acid. So what will happen? There will be a new bond formation between this sulfur and this carbon. Then what is the leaving group here? HBr. H and Br will go out. And this is again condensation reaction. So lone pair or the bond pair present on the nitrogen can react with this carbon and water will go out. It's a condensation reaction forming a 1,4 thiazepine. So similarly, small changes. This is a alpha beta unsaturated ketone, and this one is amino mercaptal. This group is amino, and mercaptal means SH. So what will happen here? Also condensation reaction, removal of water H2 and O, and there will be a new bond formation between this sulfur and this carbon. So and of course this bond pair can come over here and form a hydroxy group. So later on, what will happen? This bond pair can come over here and this will go out. So overall, a condensed product is 1,4 thiazepines. Okay, this is about 1,4 thiazepines. So that means with this, I will go to the next slide. So next slide is about the chemical properties, more particularly chlorination of thioethers. Okay, so you know that this is a thio. Okay, since adjacent positions are methyl, we can say that this may be a thioether. Of course, this is actually a 1,4 thiazepine. So here what will happen when this is uh, uh, treated with a chlorinating agent? The chlorinating agent may be a, thionyl chloride or POCl, phosphorus oxychloride, or PCl5, phosphorus pentachloride. What will happen? There will be a chlorination alpha to the sulfur. Sulfur is this is the functional group, and this one is the alpha position. Here there will be a chlorination. After chlorination, what will happen? Suppose the obtained chloro compound, when it is treated with base, okay, so it's called dehydrohalogenation. So dehydrohalogenation means this bond pair can come over here, this will go out. When it is going, it will also take the proton in presence of base, and this process is called dehydrohalogenation. Okay, so with this I will go to the next slide. uh, Next slide, that means up to this we discussed about the 7-membered ring. Okay, 7-membered ring with nitrogen containing, 1 nitrogen containing, and 7-membered ring with 2 nitrogen containing, 7-membered ring with oxygen containing. So 7-membered ring with nitrogen is called azepine. 7-membered ring with oxygen is called okay, 7-membered ring with oxygen is called oxypine. 7-membered ring with sulfur is called thiopine. So oxypine, azepine, thiopine synthesis and their chemical reactions we discussed. Similarly, suppose 2 nitrogens are there, it's called diazepine. Uh, then suppose if 1 nitrogen and 1 sulfur is it present means the what you call thiazepine. Okay, so all 7-membered ring with the nitrogen, with oxygen and sulfur, their synthesis or preparation and their chemical properties we discussed up to this. So maybe now we will move on to the 8-membered ring. Okay, so 8-membered ring with nitrogen, okay, is called azocin, AZO. Okay, AZO, aza means AZA, it stands for nitrogen. Ocin, OCINE, ocin, it stands for a 8-membered ring. Okay, so azosine is the an example of 8-membered heterocyclic compound. So if we are looking into the preparation, so most of highly unsaturated. So you know that 8-electron system. So 8-electron system means it's not a aromatic one. It is a non-aromatic